Hi guys, here's a video that's going to help you get prepared for your final exam. It goes over the multiple choice review packets. Number one, you're just factoring. Hopefully you already know how to do this, so I'm not going to go over these. Number one, part A is B, and then for B, your solutions should be D. For number two, to solve this, we can use a quad program, get this equal to 0. So I have 10x squared minus 13x minus 3 equals 0. So I'm going to go ahead and go to my handy dandy calculator over here. Hit program, quad. A is 10, B is negative 13, C is negative 3. It gives you 1.5 and negative 0.2, which is equivalent to 3/2 and negative 1/5. For part C, I'm going to go ahead and try and use the quad program again. So that gives me 2 for A, negative 6 for B, and 3 for C. And if you notice, you get these decimals over here, which means we have irrational solutions. So if you look at all your answers, they had radicals anyway. So that's an indicator that you would actually have to work through the quadratic formula. So I have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So yeah, that gives me 6 plus or minus the square root of 36 minus 24 is 12 over 4. 12 is the same thing as 2 root 3. And then all three of these numbers are divisible by 2, so I'm going to go ahead and divide both of those by 2. And that gives me with 3 plus or minus root 3 over 2. So my solution for that is going to be C. For number 4, I'm going to go ahead and start by taking the square root of both sides. Because the square and the square root cancel, I'm left with 2x plus 6 equals plus or minus. Square root of 28 I can reduce to 2 root 7. Subtract 6 from both sides. Divide both sides by 2, and you get x equals negative 3 plus or minus root 7. So my answer for that is A. Number 5, I'm going to isolate my radicals, so I'm going to add x to both sides. So I get the square root of 2x plus 7 equals x plus 2. I'm going to go ahead and square both sides. Square and square root cancels, so I have 2x plus 7. Over here with the x squared plus 2 quantity squared, so x plus 2 quantity squared, you need to actually multiply it out. So you can square double square it. So that gives me x squared. Multiply these two and double it. Square your last term, so there's your square double square. Get it equal to 0. So I have 0 equals x squared plus 2x minus 3. You can use a quad program to solve this, or you can just factor it. So I get x plus 3 and x minus 1. So my possible solutions for x are at negative 3 and 1. Now before you circle C as your answer, you do need to double check your solutions, which I'm going to do in red. If I take negative 3 and plug it in, minus negative 3 becomes plus 3. I want to see if that equals 2. Well, that gives me 1 plus 3 does not equal 2. So that means my only solution for this is that 1. So my correct solution for this is going to be B. So don't forget to double check your solutions, especially when you're dealing with radicals. Number 6 is going to do the same thing, so I'm going to add 1 to both sides. So I get the square root of x minus 16 equals 3. I'm going to go ahead and square both sides. Square root cancel, I'm left with x minus 16 equals 9. Add 16 to both sides and you get x equals 25. So my answer is D. That was a really easy problem. This problem should have came before number 5. For number 7, you want to get rid of your fractions. So my common denominator with all of this is x squared minus 9. So I'm going to go ahead and multiply everything by x squared minus 9. So I have 2x over x minus 3 times x squared minus 9, which I'm going to write in factored form, x plus 3x minus 3, minus 2 times x plus 3x minus 3 equals 6 over x squared minus 9 times x plus 3, x minus 3, running out of space. So over here, my x minus 3's cancel, and I'm left with 2x times x plus 3. Over here, nothing cancels, so I'm left with minus 2 times x squared minus 9. I'm going to go ahead and multiply that out. And then over here, everything cancels, so I'm left with equals 6 distributes, and that gives me 2x squared plus 6x minus 2x squared plus 18, don't forget to distribute the minus completely, equals 6. My 2x squares cancel, so I'm left with 6x plus 18 equals 6. Continue to solve, 6x equals negative 12, so I get x equals negative 2. Number 8, I'm going to do the same thing, my common denominator for this. Once I factor this quadratic down here, I have x plus 3 and x minus 2, so that's going to be my common denominator. So I'm multiplying everything by x plus 3 times x minus 2. So there's my first fraction, second fraction, and then my third fraction, and then I get cancel happy. These are going to cancel. I'm left with x plus 3. These are going to cancel. I'm going to go ahead and distribute the 3 right away. So that leaves me with 3x minus 6. These are going to cancel, equals 4. Combine your like terms. Add 3 to both sides, divide both sides by 4, and you get x equals 7/4. So my answer for that is going to be D. For number 9, I'm going to go ahead and isolate the absolute value first. So I'm going to multiply both sides by 2, and I have absolute value of 2x minus 6 is greater than or equal to 32. Now, when you're dealing with absolute value inequalities, you do need to remember the acronym Igorland. So if I have a greater than, that means I'm going to have an or inequality. If I have a less than, that means I'm going to have an and inequality. So for my or inequalities, I'm going to go ahead and separate this. So I have 2x minus 6 is greater than or equal to 32, or 2x minus 6 is less than or equal to, so I flip the sign, and I make the 32 negative, and then I can solve both of these. So I'll add 6 to both sides. I get 2x equals 38. Divide both sides by 2. That's not supposed to be an equal. Greater than or equal to 38. So I get x is greater than or equal to 19 for this first one. And then add 6 to both sides. I get 2x is less than or equal to negative 26. Divide by 2, and I get x is less than or equal to negative 13. So for x is greater than 19, that's going to be the interval from 19 to infinity. For x is less than or equal to negative 13, that's negative infinity to negative 13. And then since I have the or, I can put these two together, and my solution for number 9 is going to be B. Number 10, I'm doing the same thing, so I'm going to isolate my absolute value. So I multiply both sides by 4. So that gives me absolute value of 5x plus 2 is less than 28. I have a less than, which means I'm going to have an and inequality. With my and inequality, I'm going to rewrite it as negative 28 is less than 5x plus 2 is less than 28. So my and inequalities have my inequalities together. My or inequalities, like the previous example, have them separated. Subtract 2 from everything. That needs to be a 30. Let's erase and fix. There you go. Divide everything by 5. And I get negative 6 is less than x is less than 26 fifths. Less than or equal to, I'm going to have parentheses, and my interval goes from negative 6 to 26 fifths. So my solution for 10 is going to be C. I think my calculator over here died. Oh well. We'll use it later, I guess, if we need it. For number 11, simplify the following expression. So if I have a negative exponent, I can take this and flip it over. So that becomes 8 over 27 being raised to the 5/3. 5/3, I can take the cube root. So the 1/3 means I'm taking the cube root and then I'm raising it to the 5th power. So the cube root of 8 is 2. The cube root of 27 is 3. So I'm taking 2/3 and raising that to the 5th power. 2 to the 5th is 32. 3 to the 5th is going to be 243. So my answer for A, part A for 11, is going to be C. For part B, I'm going to go ahead and cube everything in my first parenthesis, so that gives me 216. X cubed cubed is x to the 9th. Y squared cubed is going to be y to the 6th. This I'm going to cube, but since I have that negative exponent, I'm actually going to move this to the bottom of that fraction. So 3 cubed is 27. And then x to the negative 3 would be x cubed. 216 divided by 27 is, I'm assuming it's going to be 8. Yes. And then x to the 9th over x cubed is going to be x to the 6th. And then finally y to the 6th. So my correct solution for B is going to be C. I paused the recording and I fixed the calculator, so we're good to go. Part A, you can actually plug right into the calculator, so I'm going to take 27 divided by 8 and raise it to the negative 5/3. Gives you this lovely decimal. We can math frac it to change it to a fraction, and you get the 32 over 243. So there we go. For number 12, this is your g function. You're finding g of negative 3. So g of negative 3, I'm just going to plug in negative 3 for x. And I got my handy dandy calculator. So I have 2 in parentheses, negative 3 to the 3rd power minus 8 times negative 3 squared minus 2 times negative 3 plus 5. Oh, forgot my plus. Gives me negative 115, so my solution for 12 is going to be A. For number 13, if f of x is 4 minus x squared and g of x is x squared, or x plus 2, find f of g of x. So I'm taking my g of x, which is inside my parentheses, and I'm plugging it in for x into my f function. So that's going to equal 4 minus x plus 2 quantity squared. So I'm taking this, plugging it in for that x. So that's 4 minus square double square this, so that's x squared plus 4x plus 4. And then that leaves me with 4 minus x squared minus 4x minus 4. So I get negative x squared minus 4x. Solution is A. Number 14, I'm finding 3 times g of f of negative 2. So I'm going to go ahead and start by finding f of negative 2 first, which gives me negative 2 squared plus 4 times negative 2 plus 5. I'm going to go ahead and jump to here. So negative 2 squared, forgot my 2, plus 4 times negative 2 plus 5, which equals 1. So I'm going to find g of 1, which gives me 1 minus 7, which is negative 6. And then I want to take 3 times g of f of negative 2, Well, g of f of negative 2 is negative 6, so I have 3 times negative 6, which is negative 18. So my solution for 14 is B. 15, find g minus f of x. So basically I'm taking g of x minus f of x. So my g of x was 4x plus 3 minus 3x squared plus 7x minus 2. So that's going to equal negative 3x squared. 4x minus 7x is going to be negative 3x. 3 minus negative 2 is going to be plus 5. So my solution is A. Find the domain of f of x. Well, your domain are your possible x values. Since you do have this radical, you can't take the square roots of negative numbers. So x plus 4 has to be greater than 0. It can't be equal to 0 because you're dividing, and you can't have 0 in the denominator. So x has to be greater than negative 4. In interval notation, that's negative 4 to infinity. So my correct solution for this is going to be B. 17, find all the values of x such that f of x equals x plus 1 times x squared minus 4 is greater than 0. For this, I'm going to go ahead and make an interval chart. So I'm going to factor this completely. So I have x plus 1. It gives me x plus 2, x minus 2 is greater than 0. So my critters, my critical values are negative 1, negative 2, and positive 2. So my first interval is going to go from negative infinity to negative 2, parentheses, because it has to be greater than 0. Second interval, negative 2 to negative 1, negative 1 to 2, and then finally 2 to infinity. I'm going to put my factors on this side. So I have x plus 1, x plus 2, x minus 2, and we are multiplying all of those together. I'm going to go ahead and draw some lines. To make the table easier to read. Okay, so I'm picking a number in this interval, so say negative 3. If I plug it in here, it's going to be negative. In here, negative, negative. 3 negatives when you multiply gives you a negative. Negative 2 to negative 1, I'm going to say negative 1.5. So that's going to be negative, positive, negative. So that's going to be positive. Negative 1 to 2, I'm going to say 0. So that's positive, positive, negative. So that's going to be negative. 2 to infinity, let's say 3. All of those are going to be positive. So we were looking for where it was greater than 0. So that was the interval from negative 2 to negative 1, union with 2 to infinity. So my correct solution for 17 is going to be D. Now you can actually do this on the calculator if you want to. I'm going to go ahead and graph this. So in my y1, I'm going to put x plus 1, and then x squared minus 4. Now we are looking for the portions of the graph where it's positive, where it's greater than 0. And that's this portion of the graph over here, where it's positive, greater than 0. So that was from negative 2 to negative 1. And this portion of the graph over here as well, which is from negative 1 to infinity. So it gives us the same solution without making the table. And you can do it however way you want. Since your final is multiple choice, if you want to just do it on the calculator, by all means, go for it. Number 18, describe the transformations of the graph of f of x equals x cubed for the graph of g of x equals x plus 5 cubed minus 9. So you're basically telling me how this is different from this. Since I have the plus 5 in here, I am moving 5 units to the left. And then the minus 9 means I'm moving 9 units down. So my correct answer for 18 is going to be C. For 19, the negative means you are reflecting over the x-axis. So reflecting over the x-axis, I think all of these, well, we can eliminate C because that's not reflecting at all. Okay. This is moving 8 units to the left and 10 units up. This one says 8 units to the right, so we can eliminate that. This one also says 8 units to the right. So our answer for 19 has to be, oh, that is 8 units to the right, just kidding. Let's start this one over. So I have the negative, which reflects it over the x-axis, so I can eliminate C. This is 8 units to the right, so that says to the left, so I can eliminate that. 10 units up, both of these says 10 units up. For my 3/4, that is a vertical compression, which in these terms is the same thing as a vertical shrink. So my answer for 19 is going to be D. So vertical shrink is the same thing as compression. Number 20, write the equation for the given graph. So you're basically taking, this is your square root function. We're taking the square root function and we're shifting it around. So I'm shifting it 2 units to the right and 4 units down. So if my original function was y equals the square root of x, to move that 2 units to the right, I would have to subtract 2 from the x. And then to move it 4 units down, I need to shift my function 4 units down. So my correct solution for this is going to be A. For 21, for each of the functions, determine if they are even, odd, both, or neither. So if you're trying to figure out even, odd, or neither, you're looking at f of negative x and comparing it to f of x. So if I have part A and I have f of x equals 4x squared plus 8x minus 2, I'm going to go ahead and find f of negative x. So if I have f of negative x, that's going to be 4x squared over here minus 8x and then minus 2. So I'm comparing this to my original function. If f of negative x equals f of x, then it's even. So f of x equals f of negative x. For something that's odd, that's when f of x is going to equal negative f of negative x. So if I try to take out a negative 1 from here, and I want to see if that equals f of x, then that would be odd. In this case, for part A, it doesn't work. So for part A, my solution is D, neither. For part B, I have f of x equals absolute value of negative x plus 3. If I do f of negative x, so that gives me, oh, I have an extra negative there. Sorry about that. So there's my original function. And then I do absolute value of negative x plus 3. Well, that's just the same thing as absolute value of x plus 3. So I have f of negative x equals f of x. So for letter B, we have a function that is even, so A. For C, if I look at f of x, which equals x cubed minus x, and then I look at f of negative x, that gives me negative x cubed plus 2x. If I try to factor out a negative, that gives me x cubed minus 2x. So this is the same thing as negative f of x. So in this case, it's going to be odd. I'm going to put a negative right here. So f of negative x equals negative f of x. So I need to get rid of that extra negative there. There we go. So that's how you can tell the difference between them. 22, to find the inverse, I'm going to write this as y equals 2x minus 3. I'm going to switch my x's and y's, so I get x equals 2y minus 3. Solve for y, so add 3 to both sides. Divide by 2. And I get y equals, if you notice, you don't have any of these for your answer, so they must separate it. So that's 1/2 x plus 3/2, which just so happens to be letter B. For 23, to find the x-intercepts of your rational function. So x-intercepts is when your numerator is equal to 0. So I have 3x minus 5 equals 0. Solve for x, you get x equals 5/3. So when I take 5/3 and plug it in, it's going to be 0. So my x-intercept is going to be C, 5/3 and 0. For 24, use long division to divide 4x cubed minus 8x squared plus 5x minus 2. So I'm going to put my 2x minus 3 on the outside. On the inside, I'm going to put 4x cubed minus 8x squared plus 5x minus 2. I'm looking at my first term. So I'm thinking to myself, what times 2x is going to give me 4x cubed, and that's going to be 2x squared. I'm going to multiply both of these by 2x squared. So that's 4x cubed minus 6x squared. I'm going to draw my line and change my signs. And then I can combine. So that leaves me with negative 2x, and then I can bring down my next term. What times 2x gives you negative 2x, and that's going to be negative 2x squared. Now if you look up here, we can already figure out some of our answers. So since I have a 2x squared, I can eliminate d. I have a minus x, which means I can eliminate b. So if you didn't know what to do next, you could take a guess. And you'd have a 50-50 chance of getting it right. But let's continue. I'm going to multiply this by negative 1x. So that gives me negative 2x squared plus 3x. I'm going to draw my line and change my signs. And that gives me 2x minus 2. And then what times 2x gives you 2x? Well, that's just 1. Multiplying this by 1, so that gives me 2x minus 3. I can draw my line and change my signs. And then 3 minus 2 is 1, so my remainder is 1. So here's my quotient, here's my remainder, so my solution for 24 has to be A. 25, use synthetic division. So I'm going to go ahead and put my negative 1 in my synthetic division box, listing out my coefficients. So I have 4x cubed. Didn't even put the 1 there. There you go, negative 1. I have 4x cubed. I'm missing some terms, so I'm going to go ahead and put zeros in its place. So I have 0x cubed, or 0x squared, minus 3x plus 5. First term goes straight down. Multiply these two. Combine, multiply, combine, multiply, combine. Since my problem started with an x cubed, my solution is going to start with an x squared. So that's 4x squared minus 4x plus 1 plus 4 over what I divided by, which was x plus 1. So my solution for this is C. 26 for my horizontal or slant asymptotes. You have 3 scenarios with your horizontal or slant asymptotes. In this case, we are going to have a slant, which is the same thing as oblique asymptote, because our degree in my numerator is 1 more than the degree in the denominator. So I'm going to go ahead and use synthetic division to divide it out. You can use long division as well, but I have negative 1. I have 1x squared minus 1x plus 0. First term goes straight down, so I have 1. Gives me negative 1. Negative 2. And that gives me 2. In this case, we don't really have to worry about the remainder. So we have the x squared, so this is going to be x minus 2. So my slant asymptote is going to be x minus 2. Find the vertical or the slant asymptotes for this. Since my degree in my numerator is the same as the degree in the denominator, my horizontal asymptote is going to be x equals a over b, so in this case 2 over 1, which is just 2. So my answer for this is going to be horizontal asymptote. It needs to be y equals, not x equals, y equals 2. So 27 is going to be D. 28, find the vertical or horizontal asymptote. Since my degree in my denominator is bigger than the degree in the numerator, this is vertical asymptotes, not horizontal asymptotes. I should read the question first. So vertical asymptotes are the zeros for your denominator. So my denominator was x squared minus 4, so I'm looking for when x squared minus 4 equals 0. Sorry about that, guys. So I have one at -2 and +2. X equals, because it needs to be vertical. 29, divide then express your answer in standard form. So I need to multiply by the conjugate. So my conjugate of my denominator is going to be 1 plus 2i. And then this I just need to multiply out. So 8 times 1 is 8. 8 times 2i is 16i. -7 times 1 is -7i. I'm basically foiling it out. Minus 14i squared. Over, this is going to end up being 1 minus 4i squared since my middle terms are going to cancel. So in my numerator, this I squared is -1, so I have 8 plus 14, which is going to be 22, plus 9i over 1 plus 4, which is going to be 5. And they want it in the standard form, a plus bi, so it's just being separated. So that's 22/5 plus 9i over 5. So my correct solution for 29 is going to be D. And then 30, multiply, then express your answer in standard form. This you can multiply on the calculator if you want to, or you can FOIL it out. 6 times 2 is 12. 6 times -3i is -18i. -2 times 2 is going to be -4i. And then plus 6i squared. So that gives me 12 minus 6, because I squared is the same thing as -1. And then minus 22i. So my solution for that is going to be A. Let's use the calculator. So I have 6 minus 2i times 2 minus 3i. Whoops. Second decimal for my I. Gives me 6 minus 22i. So my correct solution for 30 is going to be A. Alright, I'm going to go ahead and stop this video right here. So this is going to be part 1. Part 2 is going to start with 31 and take you up to number 60.